Hello students, welcome to this lecture. So in this lecture we are going to see about the Watchdog timers and the real-time clocks. So these two types of timers are the main applications of timers. So in the previous video we have discussed about some of the applications of the timers. So in those we have seen two types of timers. One is Watchdog timer and another one is real-time clock. So Watchdog timers are a special type of timers used in microprocessors and microcontrollers in order to watch the working status of the particular processes on the hardware units whichever you are using in your embedded systems. So the Watchdog timer is an electronic or a software timer. By both ways we can design the Watchdog timers. In most of the cases the microprocessors having the software timers as installed inside the software of the microprocessor. So that is used to detect or recover that particular computer application from the malfunctions of the particular computers. So during normal operation, the computer the microprocessor will be regularly resetting that particular timer whenever that particular Watchdog timer will be reaching that particular preset count value. So that particular timer will be resetted. The Watchdog timer will be thinking that the particular processor is in the normal state. Okay, so whenever that particular Watchdog timer is being resetted, the Watchdog timer will be thinking that particular processor is in correct and working state. And if any faults are occurred in that particular processor or in the hardware or any of the program errors that can be occurred, because for some of the softwares also the Watchdog timers may be designed. So if that particular software doesn't or the particular RTOS doesn't reset that particular Watchdog timer, then that Watchdog timer will be thinking that that particular software or a hardware for which the Watchdog timer has been designed, there was an error. So so that particular computer or the software fails to reset that particular Watchdog timer, so the timer will be elapsed, because the timer will be elapsed if it was not if it was not resetted properly. So the timer will be elapsed, so the timeout signal will be given, and upon reception of that particular timeout signal, the corrective actions for in order to save that particular software or the hardware, the corrective actions have to be taken. So the corrective action may be placed inside a computer system as a safe mode, or that particular software or the RTOS may be revoked into the safe mode. So that particular software will be invariably it will be revoked into that particular safe operation zone. So for these kind of applications, the Watchdog timers are mainly used. For other applications also, we can design the Watchdog timers, because the Watchdog timer is not on specific or it is not on special hardware. It is essentially it is on timer, but that particular timer is being used for specific applications. So for that only this particular Watchdog timer is going to be a special one. So the other applications that can be used are in mobile phones. Two applications have been mentioned here. So the mobile phone with the auto off facilities, because the mobile phone displays may be set as an idle when no GUI is opened. So at that time the display will be consuming more power. So if that particular display is getting idle when no GUI is open for a specific time, then if that particular timer will be getting on, so if we set that particular Watchdog timer at this time, If that particular time is being elapsed, so the watchdog timer will be giving the reset signal and timeout signal, so that the particular mobile phone's display can be off. So for this application we can use the watchdog timer. The other actions which are taken as timeout status for apps of the mobile phones, we can use those particular timeout actions for that particular operations of the apps. So if any of the app is accessing the data in the network servers or in bank servers um, or any of the applications which are related to the medical diagnosis like this. So those kind of applications may be set up with these kind of watchdog timers, so that that particular process or if any servers in the remote side, if they are not responding up to one given time, so the timeout signal may be generated by these particular watchdog timers, so that the corrective actions can be taken. So for those kind of applications we can use these watchdog timers to be set in the mobile phones. And the third application can be in temperature control. If the controller, if that particular controller is in failure mode, so if that controller doesn't take any action upon the increasing nature of the temperature beyond a certain value for a given specific time, so the controller or the watchdog timer will be watching to that particular increasing temperature, but the controller is not in mode to taking control of that particular action, particular situation, then that particular watchdog timer may be given as in privilege mode. So in a specific time, if that particular controller is not turned up, then this particular watchdog timer may be giving the timeout signal. So upon that, the correct actions may be taken by the standby mode controllers also. So this is how the watchdog timers may be used in the embedded systems. So next we will be seeing about the real-time clock. So here we are going to discuss about the real-time clock. Then the very popular real-time clock is going to be PCA 21125 IC. So the block diagram of that particular IC has been given here. Here the blocks of the ICs can be viewed, that the oscillator circuit has been given. So the monitor and the power and reset was given here. So we will be discussing about this particular in the next slide. And the divider has been given. So the oscillator circuit will be generating this kind of this much amount of clock signal. So that particular clock signal has been given into this divider. So this divider will be given to that particular memory segment on that particular real-time clock. So in this memory segment we will be given some of the software timers. So the software timers can be programmed to making the timer to be run in a continuous mode, because the real-time clocks having the character that it won't be getting resetted, or it won't be getting off. So that particular time tick will be given as an input to this particular memory block, or the software timer block. So that software timer will be updating this particular clock ticks into the seconds, and if 60 seconds has been finished, the minute will be updated. So if the 60 minutes has been finished, the hour will be updated. If 24 hours has been updated, so 1 day will be updated. So likewise it will goes on up to the years. So the alarm functions can also be declared, and the alarm functions are eventually declared inside the memory, that minute alarm, hour alarm, day alarm, and the weekday alarm. So depending upon the particular situation has been arised, so those kind of alarms can be generated, and that particular alarm will be given to the interrupt module of this particular IC, so the interrupt will be generated. So depending upon the particular timing and the particular signal which has been given to that particular serial communication module of that of this particular chip, the data will be getting updated to the external circuit. So this particular updation of this particular timing will be communicated to this SPI interface, that is the serial peripheral interface. So this serial peripheral interface will be giving the data output, and data input can also be get from this from the microprocessor which is being connected through the serial communication module of that particular microprocessor. So the data may be got input to this particular serial communication, and the updation of this particular timer will be given for every second of this particular updation of the timing. So because the seconds will be updated at every second, so the second and the other information which are stored here will be updated to this particular SDO pin of the SPI interface in this particular chip. So also the clock signal which has been synchronized with this particular real-time clock, and this particular clock and the oscillator input clock will be synchronized to each other, so that we will be having that particular real-time clock is synchronized with the clock frequency of the particular microprocessor. So the synchronization work will be done only with the help of the microprocessor, and the other pins are going to be ground and the power pins which is being given here. So this is all about this particular section, and here we can get the the reference clock signal from this particular real-time clock for making this particular real-time clock to be synchronized with to synchronize other processes in this particular system. So in order to synchronize those processes inside that particular embedded system can be done with the clock out signal from this particular real-time clock. So this is how we can model, or we can use this particular chip inside our embedded system. And in some of the modules of some processors are dealing with this kind of real-time clocks, and there are many chips are available in the market, like whichever the module we are seeing here, the architecture is going to be the same. So that's all about this particular real-time clock, and we need to see some of the features of that particular real-time clock, that the microprocessor can be used to read this particular real-time clock using the serial interface, and the software performing functions in those particular microcontrollers or microprocessors can be synchronized with this particular real-time clock. So since that particular software performing functions can be time dependent, so that can be synchronized with using this particular real-time clocks which are external to that particular microprocessor. And the real-time clocks are really going to be ultra low power consumption wise ICs only, and here in this type of ICs there will be some power consumption capabilities and power consumption functionalities are also being designed, and they are programmed inside, so that we can make those particular type of real-time clocks into a sleep mode, or they can be started or they can be stopped also. And these kind of applications are going to be in power consumption point of view only, because if you are making those kind of functionalities, then the clock will be getting deteriorated. So in order to making those kind of abnormalities in the view of that particular power consumption, the clock will be rearranging itself, but the updation of the real time cannot be detried at all. So wherever we are having that kind of battery related problems or power consumption related problems or power related problems, the RTCs will be tuning themselves in order to updating that particular real time without any flaws. So that is the main motto of this particular power consumption control capabilities and the low power consumption capability of the real-time clock ICs. And they can be frequently integrated into other devices, and the external crystal oscillator for 32.768 kHz can be used, but using this quartz crystal may be somehow temperature dependent, because depending upon the load of that particular microprocessor which is being connected with this particular serial communication, will be getting that particular crystal to be loaded at some time, so that the temperature may be raised. So in order to avoid the particular temperature rise, will be pushing up more current into the RTCs. The RTCs will be having integrated temperature compensation units, so that the accuracy of the crystal oscillator may not be detracted. So in order to alleviate that problems may be alleviated by the crystal aging, but the very old crystals may be getting replaced by the users as frequent as possible. So that is going to be the limitation in the real-time clock circuits. But we may be having that particular type of real-time clocks to be operating up to 25 years too. So those kind of practical applications are also available. So that is not a problem at all for the real-time clocks to be used in the real-time in nature. So thank you.